Dear participants, I welcome all of you in this lecture of data pre-processing, where we will discuss feature scaling, transformation and discretization. In last class, we discussed how to handle missing values. So, we have seen three different ways through which we can handle the missing values. The first one was to delete those records having missing values. The next one was to delete that particular feature which are having missing values, and the third one, that was the most ideal solution, was to fill empty values with certain values, let's say minimum value or mean value or median value and so on. Next, we discussed class imbalance problems. So, and its remedies, or you could say solution, and the solution was to oversample the data, or you could say instances, or undersample the instances, and you can also apply smooth. So, these we discussed in last class. In current class, we will discuss feature scaling, where we will see mean max scaling and normalization, standardization. So, that we will discuss in feature scaling. Then we will move on to discuss transformation of categorical data into numeric values. And the third that we will discuss, that is discretization. And discretization is actually the inverse of this particular transformation of categorical data into numeric values. So, in discretization, we are actually converting the numeric value into categorical data. So, what is feature scaling? The very first question is, what is the purpose of feature scaling? So, feature scaling is a method used to standardize the range of independent variables or feature of data. The primary goal of feature scaling is to ensure that no single feature dominates the others in terms of scale, right? So, which can lead to biased or skewed result in algorithm. So, we want to have a common scale of the data inside the feature. So, here you can say, so although the data are on different scales, now after the feature scaling, the data is in single scale. So, that is the purpose of feature scaling. So, most probably our data set comprises of the attributes with varying scale. So, the data would be like age vary from, let's say, 30 to 80, and salary varies from let's say 10,000 to 2 lakhs and so on. So, each is on different scales. So, if a feature in the data set is big in scale compared to others, then in algorithms such as KNN, that is K nearest neighbor, where Euclidean distance is measured, this big scale feature becomes dominating. So, the feature having big scale values would be dominating. So, feature rescaling makes sure that attributes are at same scale, whether it is between 0 to 1 or -1 to 1 and so on. There are two common ways to get all attributes to have the same scale. One is minimum maximum scaling and standardization. So, that we will discuss in today's class. So, what is mean max scaling? So, in mean max scaling, which is a very simple one, values are shifted and rescale so that they end up ranging from 0 to 1. So, what we are doing in mean max scaling, we are subtracting each and every value of the feature with minimum value, and then dividing with maximum minus minimum. So, this is the minimum mean max scaling. So, in this way, the whole data would be in range of 0 to 1. And the next one is and how to apply min max using scikit-learn. So, first we will import mean max scaler. You can also import, you can also write this one in this manner as well, from scaler dot preprocessing import mean max scalar. So we can write in this manner as well. And now we can use this module only. Instead of prefixing with pre-processing, you can directly use min max scalar, right? So in this way, you can use min max scalar. So it would range the whole data between 0 to 1. If you want to make your range other than zeros and ones, so you can modify this one also. Let's say you want to make your scale between -1 to 1. So you can write these values as well. Now the next type of scaling that we usually call normalization. So instead of using mean value in the previous case that we had seen, we will be using the average value. So what we are doing here, we are subtracting the value with mean value. So in previous case that we have seen mean max normalization, we have seen the value here minimum value. So instead of minimum, the mean value should be there. So first value is subtracted from the mean value and then it divides by the maximum minus the mean. Now the next one is standardization. So standardization is quite different. First it subtracts the mean value and then it divides by the standard deviation, so that the resulting distribution has unit variance. So in this case, the variance would be would have unit variance. So standardized values always have a zero mean, and the beauty with standardization is that standardized value, that is this value, would always have zero mean. So if you would identify the mean of all these values, so you would find the value as 0. And how to apply standardization? So first I will import a standard scalar. Again you can write standard scalar. You can directly import a standard scalar, right, that we had seen in previous min max scalar. And first you need to fit you need to apply fit underscore transform method to make the value, or you could say to rescale the value based on standardization, standard scalar, based on standard scalar. Now this value would have values between -1 to 1. Actually standardization would give value between -1 to 1, and it would have 0 mean. Now how to apply standardization and actually the scaling approach? I'm switching to the Google Colab, where I will discuss how to perform feature scaling. So let me load the diabetes dataset. So here I'm looking for diabetes dataset. Yeah, this one. So I've executed this one, and then I'm also executing so that I can get X and Y value. Now I would apply standard scalar first. Yes, this one is standard scalar. So before that, I will try to show you the value of X so that we can differentiate how the scaled value will differ from the previous value. So I'm printing here, print X, right? So you can see the values here, right? Now I am applying a standard scalar, right? Then scaling dot fit and scaling dot fit transform. So let me execute this one. Sorry. So no, it's a X dot sc. Sorry, I'm commenting this one, and X dot sc. Yeah, execute this one. So you can see here all the values are between -1 to 1. Yeah, these are individual values. So we are having how many features are there? 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, and 8. So 8 features are there, and 1, 2, 3, and there are certain dots here. It means there are certain features, and then other ones. So this one is the very first record, second record, and so on. So it has standardized the whole values between -1 to 1, right? So that's why in this way we can standardize. If you want to use mean max scale, mean max scaler, and then use this one, and mean max scaler, yes, scaling, yes. So let me execute this one. No. So mean max scale has given the value between 0 to 1. You can see here. So these have been scaled. So in this way we can apply the feature scaling. So we had seen mean max scaler and standardization. So now I am switching to the PowerPoint. So we had seen mean max scaling and standardization. Now we'll discuss converting categorical data into numeric values. So imagine you have a data set with a feature color, and the possible values are, let's say, red, blue, and green. So these are categorical data in text form. And if you want to, how we can convert these categorical data into numeric values, right? So for that purpose, we will be using ordinal encoder and one hot encoder and so on. So actually most machine learning models are designed to work with numerical inputs such as KNN. And to convert categorical data into numeric values, for that purpose, we are having, let me select the pen first. Yeah. So we are having ordinal encoder. Yeah. So ordinal encoder, I already discussed that it convert the categorical data into numeric value in the form 0, 1, 2, and so on, right? So the transformation would look something like if you are having category, let's say you are having category X, Y, Z. So X would be assigned 0, Y would be assigned 1, and Z would be assigned with 2. So in this way it would be categorized. So here I am trying to categorize ocean proximity, which are having 5 different categories. So 0 to 4 would be assigned to this particular feature. And one issue with ordinal encoder is that machine learning algorithms will assume that 2 nearby values are more similar than 2 distant values. Let's say you are having 5 different categories, and you converted categorical data into numerical values. So it has generated these values. So what machine learning algorithm would treat? It would consider that these two values are more similar as compared to 0 and 4. But actually there is no such relationship as far as categorical data is concerned. Like if you are having different colors, like let's say red, blue, green, yellow. So these are no such relationship, right? So blue is not near to green and green is not near to blue, right? So we are not considering the numerical value of RGB, right? So for that purpose, another technique is used, which is called one hot encoding or one hot vector. It actually gave one attribute equal to 1, that is hot, while the others will be 0. It means if you are having 3 category, let's say, so at a time in your data set, at a time only one category will be there, right? In actual record, only one category would be there. So it would assign 1 to that category and the rest would remain 0, right? So that is the purpose of one hot encoder. So the new attribute are sometimes called dummy attributes. So the new attributes are, so these would be treated as attribute actually, or you could say feature. Scikit-learn provides a one hot encoder class to convert categorical values into one hot encoder. So this is the module that we call one hot encoder that would be used to convert categorical data into numeric values, and it will internally creates several dummy attributes related to the categories. And let me switch to the Google Colab so that I can discuss the this step, converting categorical data into numeric values. Now I'm trying to load housing data set. Let me execute this one. So in housing data set, we are having one categorical data, that is ocean proximity, right? Which are having different categories. And how to check the different categories? Just I will write print and then df1 dot group by ocean proximity and then write cont here, and let me print this one. So you can see here these are different categories: less than 1 hour ocean, inland, island, nearby, and near ocean. So these are number of records that are available related to this category, and related to inland the number of categories are 6,551 and so on. So these are different categories that would be assigned certain numeric value. We will try to assign certain numeric values to these categories, and for that purpose we will be using ordinal encoder first, and then we'll move on to discuss one hot encoder. So in ordinal encoder, first what we need to do, we need to store this value, that is ocean proximity. First I am storing this value in this housing category. Why I am storing? Since I would delete this feature later on, and I would add one new feature which would have numeric values, right? And I would pass this data to ordinal encoder, and it would transform the data into numeric value, right? Now after that I am dropping the this particular feature, that is the column, you could say, ocean proximity, and later on I am adding this category to this particular feature, right? So this is the way we will perform in this activity. So it is df1, right? So it is df1, yeah, not df. Drop ocean proximity. So what it says? Oh, ocean proximity not found. So not df1. Everywhere it is written df1. So I need to write df1 and then df1. Yeah, now it should work, right? So you can see here ocean proximity is given float now, right? It means the first it was object, that is category. Now it has been converted to float value. Let me print the value as well. So I would write print and then df1 dot df1 only. So it would give me 10 records only. So you can see here, yeah, ocean proximity. So it has given numeric values, right? And similarly, I can use one hot encoder, right? So how to use this one hot encoder? I need to again execute first. Let me execute housing data first. So where is the housing data? Yeah, this one. Actually, I need to re-execute it, housing data, because my ocean proximity has been converted to numeric value because of encoder, that encoder, one ordinal encoder. Now I am trying to execute one hot encoder, right? So first I need to use 1 here, 1 and then 1, 1. So right, let me execute this one. So it has been executed here. Let me write print df, and df I'm trying to print only ocean proximity, ocean proximity. Yes, ocean proximity, sorry, df1. Yeah. So in this way, it has actually converted the data into 3 different categories and 3 different actually dummy features. And in each dummy feature, the value would be 1 that is actually related to the category, right? So internally, it would create 3 different dummy features. So in this way, we can have different way of transforming categorical data into numeric data. Now we'll see discretization technique. So discretization is a process that transforms continuous variable into discrete one, or you could say I'm trying to convert numerical value to categorical data. So that is discrete one. Discretization is a powerful method, especially when we are dealing with continuous data that our model might interpret better if it were categorical, right? So the new discrete features that result from discretization can be especially advantageous for certain types of model. For instance, decision trees and naive-Bayes classifier often perform better with discrete values. So the process starts, how actually the discretization performed? So the process starts by determining the boundaries of contiguous intervals that cover the range of our variables value. Then we categorize each original value based on these intervals. So we actually need to create different beans, and on each and every beans we'll find the relative values. So again, like in this case, we are using k-beans discretization, so that we can create a total n beans, and let's say you want to categorize let's say a certain value, a certain value which is between 0 to 1, let's say 0.3, 0.4, 0.5, 0.6 and so on. You want to make category for this continuous value. So what we'll do, we'll create different beans. Here we are creating 10 beans, and on 10 beans and then the 10 beans would be assigned on the basis of certain discrete values, and for all 10 beans the value would be assigned accordingly. Then it would give you a discrete value. In this case, here it would give you a discrete value. So this is the process of converting continuous value to discrete value, or you could say numeric value to the to categorical data. Now I am summarizing what we had discussed till now. So we discussed feature scaling, and in feature scaling we discussed minimum, mean, max scaling, normalization, standardization. Then we also discussed transformation of categorical data into numerical values. We had seen one hot encoder, an ordinal encoder, so that we discussed. Similarly, we discussed discretization, so that we can perform by creating different beans, right? So different, actually we need to identify different range of values so that we can create different beans. So on the basis of that, we will perform the discretization. So I'm stopping here, and we will meet again in next lecture. Thanks so much.